Leopards that are kept illegally are typically confiscated and repatriated elsewhere. Sometimes leopards are kept in such poor condition that they have to unfortunately be euthanized, though in most cases we either release them on the day or keep them in temporary captivity for a while until a suitable repatriation site is secured and the animals have recovered. In South Africa's Northwest Province, the state is charged with dealing with the management of threatened species such as leopards. The province is quartered into 4 districts, and each district has an appointed problem animal control officer that will coordinate all captures of leopards as required. When leopards are captured in pastoral areas with large numbers of villagers, it is important to engage with the community and to harness whatever educational opportunities there are. Another category of leopards which falls into our hands is that of orphaned leopards. In these, we seek to eventually repatriate them. An orphan state is deduced from the absence of a mother tending her cubs. We thus attempt to capture orphaned leopards and seek to release them back into the wild later on. Being young and small means that these cubs cannot be collared, but are instead kept in temporary captivity until they are old enough as subadults for release. We thus plan to simulate natal dispersals once maturity is reached. Wire snares are a major threat to leopards outside protected areas in South Africa, and we regularly extract leopards from them and treat them before re-release. Some wounds are minor around the feet, and others are circumferential around the whole front of the body. Serious cases require hospitalization, such as admitting them to Dr. Peter Caldwell's practice at Old Chapel Vets in Pretoria. Some treatments involve dental work, which is often the case with the leopards that have injured their teeth in cage traps. We are appreciative to the various reserves and private holding facilities who have allowed the temporary keeping of leopard for whatever reason, whether this be for orphans or for the recovery of injured animals. GPS collars are expensive, and none of this work would be possible without sponsors on board. The Quena Toll Company, that's road network traverses our study areas, has to date sponsored the most collars for our work. When collaring leopards, it is also an opportunity to age animals by examining their teeth and obviously doing measurements and getting blood samples too. PPC and Enviro Insight are companies that have also sponsored collars, and in the case of the former, allowed deployment on their properties. Enviro Insight have sponsored a few collars, and uniquely they are comprised of qualified field biologists, which has its perks as they are similarly experienced in the kind of work we do. Mr. Martin Zipe of Liftmaster, who lives in the Magaliesburg area, sponsored a collar too, and here he assists with the collaring. We had a second erythristic leopard to collar, and here we trialed a collar that employs car tracker technology, courtesy of the company Tract Group. This company are pioneering their technology for application to wildlife. Dr. Venter is seen here having immobilized our last collared leopard in late 2019. One of our work collaborators and his wife, Leanne Venter, secured the last few GPS collars, and she is interested in examining survivorship and probability of release success in leopards. When releasing leopards, other than considering other conspecifics on the release site, one needs to consider whether the threats that led to their original demise have been addressed. The release will either entail a relocation or a translocation, where the latter is a release of a leopard in excess of its putative home range diameter as deduced from local benchmarks. When releasing leopards, one should monitor the animal for as long as this allows. Camera traps are placed at leopard kill sites located from examining GPS clusters from their satellite collar downloads. On a daily basis, we examined each collared leopard satellite downloaded maps, and based on the geography of the area, we interpreted their behavior. Our location fixed interval varied between hourly to 6 hourly, and we would adjudge a GPS cluster as any cluster of points for at least a day and within a 100-meter diameter. Although we had different collars and thus different maps were produced, the principles remained the same. We visited the majority of clusters for each leopard with the dual purposes of confirming whether the animal was okay and recording of kill information. Here, female leopard LFO2 is on a young kudu kill within the first month of her release. This is translocated male LMO8, who feeds on a large kill of a kudu male at the Barakalada National Park. Male leopard LM12, or red for obvious reasons, was an interesting case, as he was confirmed here scavenging on the carcass of a cow. This male leopard was orphaned, and though he had been confirmed on a few kills he had made, he did rely a lot on scavenging opportunities such as this. In this case, landowners often place already dead livestock, although normally only those that have died of disease, in areas for vultures and carnivores to then feed on. This was 2 months after release, and he was in very good condition by now. What is also of interest is that other leopards sometimes appear and share large carcasses such as this, though not at the same time, of course. Here we obtained an adult female and another young male feeding on the same carcass. It did appear too, from interpreting the footage, that this male LM12 appeared to be dominant at this carcass, as these other two unknown animals typically fled when he appeared. Athena, or Ella 15, was another orphaned leopard we released on the mountain, and she was 20 kilometers from her natal area. As with previous orphaned leopard, she also killed prey and settled into a stable home range. Since she settled in a human-modified environment, she sometimes preyed upon species in such areas such as feral dogs. For predicting den sites, the same principles for doing GPS cluster examination for kills holds. The interpretation is though different, and when connecting movements are interlinked between locations, it will resemble a star, with to and fro movements to the den site, where the movements away are mostly to kill locations. Denning leopards are often situated in rugged terrain, as is indicated in the map with the browner shades, and also on larger farms, which tend to be sparser with humans, as is seen on the map with the farm overlay. When rocky areas are at a premium, leopards resort to hollows and trees as denning sites. Leopards mostly use rocky crevices as den sites for their young, and camera traps should be placed such that they are not too obtrusive. GPS cluster examination is not always about confirming the glamorous aspects of leopard behavior, such as observing leopards dismembering prey items or adorable cubs. Confirmation of mortality and its causes are very important to document, especially in the light of leopard population dynamics outside protected areas. Given the latest AWT collar technology and its wide locational error, unlike in the past, we have not been successful with being able to predict ensnared leopard and have already lost 2 leopard in the Magaliesberg since 2019 to this. Where study animals have releasable collars, the last known locations need to be walked into with a GPS for retrieval. This can be done with VHF radio telemetry and walking into the last point while searching a wide enough area. This is of course easier said than done. In many cases, the study animals simply disappear, and to locate them requires extensive camera trapping, and provided they have a stabilized home range in the area, a fine-scale map of their range use will assist in setting up a camera trap design so as to maximize detections of animals that have gone astray. In this we mean that either the satellite component has failed, or it has neared completion in battery life, or the radio telemetry component has expired. So it's simply a matter of looking at older maps of the animal from its downloads and then predicting where they might be in the future to set one's camera traps there. When the satellite component has failed, other than ground-based searching, aerial searches can be done with a helicopter or a fixed-wing aircraft, as we have done with Mrs. Owen Sutton and Gordon Holland Ramsey, who are both landowners as well as aircraft owners. Sometimes deeply incised gorges conceal leopards and their signals can only be detected from an overhead searching flight. When confirming mortality, unless the carcass is located, sometimes the animal has been captured and there is no obvious sign of mortality other than a cut-off collar, but the animal has been harvested from the area and it may be as good as dead in the sense of its function in the ecosystem. This is mindful of a very alive, illegal live trade in leopards for breeders, traders, hunters, and the like. Where there are no obvious signs of mortality, where a fresh carcass is obtainable of a dead study animal and a post-mortem with a veterinarian is possible to undertake, this is the surest way of confirming mortality cause. Half a decade ago, back in 2014, LFO2, or better known as Brandy, had to be extricated from a wire snare that had restrained her movement entirely. In this, we followed the same principles as one does when examining GPS clusters, this time to suit a conservation purpose and to basically initiate a rescue, which we had to do via airborne means. She was thus darted from a hovering helicopter and treated on site, and she had an inch-deep wound around her whole forequarters, as she had been ensnared for longer than a day or two. Since she needed urgent veterinary treatment, we airlifted her to the Johannesburg Zoo's hospital. At the Joburg Zoo, treatment began immediately, and what was quite interesting and profound was that there were more vets attending to her than what the equivalent ratio was at the local human hospital. The vets did a superb job in stitching her up, and what was discovered in the interim from x-rays was that she was pregnant. Naturally, the media got wind of this and it became a matter of saving multiple leopards on that day, which was also incidentally South Africa's Heritage Day, a national holiday celebrating heritage in all its forms. After a fortnight, she was discharged, and like a celebrity or a politician, she was collected via helicopter, while all support staff had to trudge along on the road network below. She was returned back to her known home range in her core area, and we chose a site near to rugged terrain as we knew she would soon need to seek suitable refuge for the rearing of her cubs. We released her in the standard manner from a transport crate, and her wound scar looked professionally dealt with. We increased her satellite locational downloads from 6 hourly to 3 hourly so we can accurately pinpoint denning localities. Ground truthing potential den sites turned out to pay dividends as we managed to get confirmation of cubs at one of her dens. As we entered the year 2015, post-release monitoring continued, and we visited almost all of her kill sites, and at some of them we placed camera traps. Here we obtained images of at least a cub after about 4 to 5 months, and she was feeding on a kill her mother had made. Following up on GPS clusters and the judicious placement of camera traps is an effective means of monitoring condition and status in leopards. At the time there were 2 cubs present, but they would never be seen in the same image as there was no sibling love to speak of at all. After a year, we obtained proof that one was a female and would be at the cusp of separating from her mother. After a year from this first documented litter, her satellite telemetry had failed, and after many attempts to recapture her for decollaring, we simply had not been able to do this. What we did discover, though, with aerial radio telemetry was that she was denning yet again, this time in a sandstone outcrop on the upper summit at the head of a deeply incised gorge. This was simply remarkable, given what life has thrown at her. Shorter interbirthing intervals are indicative of a population under pressure, where reproductive output is then maximized. A decollaring schedule is planned for each leopard, where this is dependent on the battery life on the collar, but also on the gender of the animal. In the case of males, where neck girth increases readily when younger, we plan for collar removal at about a year at most, but often sooner, and we do monitor this from GPS cluster-based camera trapping. In the case of females, there is less urgency as far as neck constriction is concerned, but for them, we do this in the second year of monitoring. In many cases, we recapture them on numerous occasions before finally deciding on removal. But sometimes they just decide overnight not to ever be caught again. Once leopard are caught for decollaring, it is a chance to take additional measurements to compare when they were first collared and measured, and to do a veterinary once over. There is obviously no difference in the principles when releasing uncollared or collared leopards. For uncollared leopards, we have no way of doing post-release monitoring, other than from opportunistic photographs from guides on reserves or independent camera trap surveys. Most of our satellite collars were manufactured by Africa Wildlife Tracking, or AWT. By logging into a user's system for satellite collared leopards, one can see in near real time where the animals move to and how their home ranges develop over time. Here we see this female's initial establishment month in June 2014 and her progress to over a year later. She does live in relative proximity to human development, and as has been discussed before, where she has borne the brunt of conflict with humans. The same home range data can be used post hoc to look at various underlying environmental features such as terrain ruggedness and vegetation types. Female leopard LFO3 here had a different collar type, one made by Surtrack in New Zealand and provided by Global Suppliers, a company whose members have worked extensively on the well-documented research on the Pindar leopard population. This collar gave us hourly data, and the visualization interface was different to that of the AWT collars, and points could be connected so as to depict movement pathways. This animal shifted its home range about the Magaliesberg Mountains before settling on the wooded slopes of the southern side of this mountain range. As with LFO2, here we show LFO4 with an overlay of terrain and vegetation, but this can be extended to using a cadastral layer and look at how leopards use particular farms. Here, Rommel or LMO5 is shown at a coarse scale across a greater landscape, and a comparison is made to a female further south, as in LFO4. With AWT collars, one can switch interface between a topographically more detailed satellite map and a standard lay Google Map interface. Here in LFO7, one sees clearly her home range in the proximity of nearby towns in the northwest province. and the satellite interface shows the terrain and vegetation more clearly when zoomed in. Even for translocations, one can scrutinize the movement path of collared animals until they return to their origins. Given real time or near to this is crucial when animals traverse hostile human-modified landscapes. We later experimented with a collar that uses car tracker technology, so obtained movement locations for every movement made. Here, this fine-scale movement of this male leopard, LM13, shows how agricultural landscapes are utilized. With this collar, we were able to add a virtual fence which designated a particular ranch boundary. Not unlike other leopards in the Magaliesberg, these brothers, LM11 and LM12, utilized areas near some of Africa's largest cities. Locally, they also utilized areas near human settlements too, but always late at night. We continued collaring and releasing leopard into the Magaliesberg, and this time AWT technology had somehow changed with a completely different interface to that done before. While this may be a reflection on the times, the locational area was much wider, so much so that it hindered our ability to determine the exact status of stationary collars. This is crucial for managers of leopard like ourselves. This time nearer to home, so as to speak, we released a female leopard near the capital of the Northwest, the town of Mafeking, which is historically well known for the siege of the town that took place during the Anglo-Boer War. Here this female explored widely into Botswana before returning to her home range, where she had a bimodal distribution in her home range core areas, with one core settled along a creek or drainage line and the other on a gold mine owned by Cal Gold Mine, which we found intriguing and worthy of study. From the collared leopards in the Northwest Province, retrospectively, one had to then map and calculate their home range sizes, where we did MCPs and kernel densities. Mr. Andrew Purdon of Map Scientific Services assisted me in this endeavor. Andrew has a background in spatial work on elephants in northern Botswana. For the maps to follow, all are kernel densities, with the darker grey being the 50% core use areas. For this unknown origin female, her final centroid was very near to a release site. This unknown origin female shifted away from the previously shown female and initially set up a temporary range in the north, then curled south to finally settle in the darker indicated area. Likewise, an orphaned female later on did similarly. Two subadult male brothers were released near to their natal sites, with the one male exhibiting opportunistic philopatry, and he overlapped an area where his brothers settled. This leopard settled within one home range diameter away from the release site, while others end up returning to their ranges, having covered over 4 to 5 home range diameters, and although they may survive for a while when returning, these are still seen as failed translocations. Others have failed entirely, not due to returning to their origins, but have succumbed to the elements on the release areas and have thus died before settling into home ranges. The short distance relocation of this young female resulted in her settling just peripheral to the capture origin, suggesting she was invariably a resident that was perhaps nudged north from her natal range where she was initially caught. Here a female failed to settle at all and died prematurely, while a male had not established an asymptotic home range, but ultimately died in a clash with a predator of his or another kind. Even females undergo long-distance exploratory movements and home back to their origins. This female was released 5 to 6 home range diameters away and returned after a month across an international border. Once again, even though the animal did survive and no conflicts were reported when it returned, it was still classed as a failure as the animal did not remain where it was released. After all was said and done, the MAP Scientific Services team and I looked at examining home range overlaps of leopards as a robust means of looking at home range stability. We used an adaptation of the UDOI, or Utilization Distribution Overlap Indices approach, used by Julian Fatbear, who developed this for leopards. Here, these animals were of unknown origin and showed a great deal of variation. Interestingly, resident leopards showed high UDOIs, consistently above zero point 0.4, suggesting high intermonthly spatial overlaps and clear fidelity to an area, and this was used to benchmark translocated leopard range establishment attempts. For orphaned leopards, which ostensibly represented simulated natal dispersal events, UDOIs for at least 2 animals increased from about 4 months. Translocating problem leopards afar result in very low UDOIs, owing to exploratory movements for up to 3 months. The increase in UDOIs thereafter simply signify a return to their origins.